Hello everyone, in this module we are going to learn NumPy statistical functions. So here we are going to learn what are statistical functions, and then we are going to discuss different types of statistical functions which we are going to use in a NumPy array. So what are statistical functions? Statistical functions are used for finding the maximum, mean, median and standard deviation going through each value of the input array. Now let us perform some statistical function on the array element. So the following given table are the NumPy statistical function. Now let us briefly understand about this statistical function. So our first function is numpy.amin. So basically this function is used to find the minimum value of an input array along with the given axis. Suppose you have a one-dimensional array that contains only integer values, and now if you want to find the minimum value of the given array, then this function will return the value. And also if the array is a one-dimensional array, then you can easily find the minimum value. But in the case if you have a multi-dimensional array, then it will compute from rows and columns. So here is the syntax of numpy_min function, and this is the function name, that is numpy.amin, and within this function there are mainly 4 parameters that we are going to use in a example. So the first parameter is a. This parameter specifies the input array on which we can easily find the minimum value. Next parameter is axis. So it will check the condition. If the axis parameter is 0, then it will return the minimum value from the row wise elements, and if the axis is equal to 1, then it will return with the smallest element from column wise. The next parameter is out. So this is an optional parameter and it specifies the output array where the result will be stored. The next one parameter is keep dims. This is an optional parameter, and if the value is true, then it will reduce the axis, and the result of dimension is with size 1. Now let us see an example of how to use the numpy.amin function with the integer value as an argument. In this example, first we have imported the numpy library with the license name np. After that we have created an array named as employee id by using np.array function, and inside the function we have set the integer value as an argument. Next we use the np.amin function, and within this function we have assigned the input value along with the axis, that is 0, and it will return the smallest value among the rows of a given array. So after executing this code, it displays the minimum element from input arrays. Now after understanding the numpy.amin function, we will discuss our next function, that is numpy_amax function. So basically this function is used to return the largest value of an input array along with the given axis. For example, you have a one-dimensional array that contains only integer values, and now if you want to find the maximum value of the given array, then this function will return the largest value. So basically this function takes 4 parameters, that is axis, out and kdims, and by using these parameters we can easily get the maximum value from a given array. Now let us have a look at the syntax, understand the working of numpy.amax function. So numpy.amax is the function name, and within this function the first parameter is a, that defines the input array on which we can easily find the maximum value. The next one parameter is axis. So by default it takes a none value and it will check the condition. If the axis parameter is 0, then it will return the maximum value from the row wise elements, and in the case of column wise we will take axis is equal to 1. Our next parameter is out. So basically this is an optional parameter and it specifies the output array where the result will be stored. The last parameter is keep dims. It is also an optional parameter. It will check the condition. If the value is true, then it will reduce the axis, and the result of the dimension is with size 1. Now we will see an example and compute the maximum value of a 2-dimensional array. So in this example we have just created an array named as number of pens sold by using the np.array function, and within this function we have assigned the integer values. Next we use the np.amax function, and within this function we have assigned the input array along with the axis, that is 0, and it will return the maximum elements in the order of row wise. Now if you want to get the maximum number column wise, then you can easily change the axis, that will be the 1, and passed as an argument in numpy.amax function. So after executing this code, the output comes maximum value row wise and the maximum value column wise. Now we will understand our next function, that is numpy.mean. So basically this function is available in the NumPy module, and we can say that the mean specifies adding all the elements of the arrays and dividing it by the total number of array values. In general word, we can say that it is used to calculate the arithmetic mean along with the specified axis. Now we are going to use the numpy.mean function to find the mean values of an input array. So in this example, first we have created an array named as sample numbers by using np.array function. So after creating an array, we have to find the mean value of a given array. So for this we have used the np.mean function, and within this function we have assigned the input array as an argument along with the axis parameter and set the value, that is 1. So after executing this code, you will get the mean value by column wise. So if you want to get the result in a row wise, then you have to set the axis equal to 0. So our next statistical function is numpy.median. So basically this function is used to find the median of the array values, and it will return the output array that contains the median values. So this function works on single and multi-dimensional arrays, and it takes mainly 3 parameters. So the first parameter is the input array, and the second parameter is the axis, and it specifies to the axis to find the median. If the axis is equal to 0, then it specifies the column, and if the axis is equal to 1, that means we have to find the row wise median. Now we will see an example by using numpy.median function. So here we have created an array named as cricket score by using the function np.array, and then we have used the numpy.median function and pass input array as an argument. So along with that, we have mentioned the axis 0 and 1, that indicates if you want to get the median value column wise, then you have to set the axis 0, and if you want to get the median value row wise, then you have to set the axis is equal to 1. So after executing this code, it displays the median of input array without axis, that is 54.0, and the median of input array column wise, and same in the case of row wise. Now we will understand next function, that is numpy.std. So basically the std stands for standard deviation, and it is used to find the standard deviation along with the axis, and this function is used to calculate the amount of variation in an array, and this method is also known as a square root of the mean standard deviation. So here is the syntax of numpy.std function, and within this function we are going to use only 3 parameters in our example. The first parameter is a, that defines the input array on which we can easily find the standard deviation. So our next parameter is axis. By default it takes a none value, and it specifies the axis on which the standard deviation calculates, and it will check the condition. If the axis parameter is 0, then it will return the standard deviation value from the row wise elements, and if the axis is equal to 1, then it will calculate the standard deviation column wise. Last parameter is out. This is an optional parameter, and it specifies the output array where the result will be stored. Now we will see an example of a numpy.std function. So we are going to take a 2-dimensional array and calculate the standard deviation of input array. So in this example, first we have created a numpy array named as random num by using np.array function, and within this function we have set only integer values as an argument. So after creating an array, we have declared a variable, that is result, and use np.std function, and within this function we have assigned the random num, that is an input array. So with this we have displaying the result by using the print statement. So after getting the standard deviation value from input array, now we have to find the standard deviation along with the axis 0, that indicates the column wise, and same in the case of row wise, we have passed the parameter axis is equal to 1. So after executing this code, so it displays the column wise standard deviation and row wise standard deviation. So our next statistical function is numpy.var. This function is used to find the variance of an input array, and it will calculate the spread of a distribution. In simple word, we can say that we must calculate the variance of a set values. So here is the syntax of numpy.var, and numpy.var is the function name. So this function takes few parameters which we are going to use in our example. The first parameter is a, that specifies the input array that contains integer values whose variance is to be calculated. The second one parameter is axis, and by default it takes a none value. Now we will understand this function with the help of an example. So in this example we have just declared an input array named as sample numbers by using np.arrange function, and within this function we have set a numeric integer value that is 12. So after creating an array, so as you can see that creation of input array is start from 0 and end with 11 value. So after creating an array, we have used the np.var function for calculating the variance of input array. So within this function we have set the input array as an argument. After executing this code, the output comes variance of the array values, that is 11.9166. Now we will understand our next function, that is numpy.ptp. So basically in Python the PTP stands for peak to peak, and it will return the range value of the input array, while range defines the maximum value minus minimum value along with the given axis. Now let us discuss the numpy.ptp function with the help of an example. Here we have declared an input array named as COVID cases by using np.array function. So we have created a multi-dimensional array. So after creating an array, we have used the np.ptp function, and within this function we have assigned the COVID case variable, that is a input array. So after displaying the range of an input array, we have also mentioned the axis parameter in it. We have set the axis is equal to 0 within a np.ptp function, and same in the next case we have mention the axis is equal to 1. So after executing this code, the output comes, the range of the input array is 178. So along with the axis is equal to 0, the range value is this, and along with the axis is equal to 1, the range value is this. Now we will understand our next function, that is numpy.average. So basically this function is used to find the average value of the input array along with the given axis, and we can also calculate the weighted average of values. So here is the syntax of numpy.average function. We are going to use only two parameters, that is the input array and the axis parameter. Now we will take an example by using the following parameters. So in this example we have created an array named as cricket score by using np.array function, and within this function we have assigned the numeric integer values. Now we have to find the average value of that cricket score values. So for this we have used the np.average function, and within this function we have assigned the cricket score variable, that is an input array. Along with that we have mentioned the axis, that is 0. So after executing this code, the output comes the average value 70. Now we will understand our next function, that is numpy.nanmin. So basically this function returns a minimum value from the given array, and it will also ignore the nan values which are available in the input array. So again this function takes three parameters for returning the minimum value from the input array. Now let us briefly understand these parameters by taking an example. Now let us see an example of how to use the numpy.nanmin function with an integer and nan value as an argument. So in this example we have created an array named as prime numbers, and within this function we have set the prime values along with the nan. So after that we have used the np.nanmin function, and within this function we have assigned the prime number. So after executing this code, the output comes the 2, that indicates the minimum value from input array. Now if you want to get the maximum value from an input array and without getting the nan value, then you have to use the np.nanmax function, and within this function you have to pass the input array as an argument. So after executing this code, the output comes the maximum value from input array without taking any nan value. So with this we have completed the NumPy statistical function.